Hello everyone, I welcome you all to Startup Academy, your online gateway to get success in ISS exam. This academy is exclusively for ISS and we have been completing the topic time series analysis and we have started with advanced time series. In the previous lecture, we did one of the major models which was autoregressive model in today's lecture, we'll discuss another major model which is moving average model. Moving average model of order Q. Now, moving average model of order Q can be represented as moving average bracket Q is defined as suppose we have xt is equals to wt plus theta wt minus 1 plus theta square wt minus 2 up till theta raised to the power q w t minus q plus epsilon. Okay, this is the model. This is moving average model of order q. Now, what does it says? Moving average model of order Q says that the time series model xt is dependent on the current value of the error term, which is Wt. I have represented it with Wt or white noise. You can say current value of the white noise and the previous Q values of the white noise. Now, this can also be of various types, but before this, let us see what it can be converted. So I can write it as xt is equals to wt plus theta, taking backward difference wt plus theta square backward difference wt up till theta raised to the power p q, theta raised to the power q backward difference raised to the power q wt. Now taking the common terms, Wt outside, we are left with 1 plus theta b plus theta square b square plus theta raised to the power q dq into Wt. And we can write this as theta b Wt. This can be written like this. So it is one of the form of the series. Now the properties of invertibility and stationary. This series, this moving average of order Q can be is first is stationarity. If theta b is less than infinity, then the model is said to be stationary. What is theta b? 1 plus theta b plus theta square b square plus theta cube b cube up to theta cube b cube is less than infinity, then this model is termed as stationary. And the second one is invertibility. What does invertibility says? Invertibility says that the roots of equation theta b equals to 0 should lie outside the unit circle. Then only the process, moving average process, is termed as invertible. So this is nothing but that this equation only. As we notice carefully, so in the previous lecture we did autoregressive series. In autoregressive series, the principle of invertibility was the principle of stationarity, where phi beta equals to 0 was the case for stationarity equals to 0 roots one case, and this one phi beta less than infinity was the case of invertibility. Okay, so these were reverse of both of them. If we want to find the moving average, invertibility function of the moving average, it is the stationary function or the stationary requirement of the autoregressive model. And if we want to find the stationarity stationarity function of the moving average, then we have to it is equal to the invertibility function of the autoregressive series. So this was it. Now moving forward, we'll do moving average of order 1. We'll start with this moving average model of order 1. Now this can be written as moving average 1. I can write it as xt is equals to wt plus theta wt minus 1. It is dependent on the one value. It is dependent on the current value of the white noise and one previous value. That means it's of order 1. So now we where white noise wt is iid white noise with zero mean and sigma square variance. So the first thing that we need to find out is mean of this process. So estimation of xt can be written as estimation of wt plus theta wt minus 1. This again can be written as estimation of wt plus theta gets outside according to the property of estimation and wt minus 1. Estimation of wt is 0 and estimation of wt minus 1 is also 0. So this is 0, which is a constant mean. Okay, so this is the mean. Now we'll calculate the variance of this method. Variance. Variance says that variance of xt is equals to variance of xt, variance of wt plus theta wt minus 1. So it would be variance of wt plus theta square variance of wt minus 1 plus covariance of wt and wt minus 1. Two covariance of. So it would be variance of wt. I told you it was sigma square plus theta square. Variance of wt minus 1 is also sigma square, and the covariance between them is 0. So it would be 1 plus theta square into sigma square when the covariance between them is 0. Now we have to find the autocovariance function. For autocovariance function, I am writing ACF, auto covariance, sorry, ACVF, autocovariance function. Now for autocovariance function, we have to find the covariance between xt and xt plus h, where h is nothing but the lag value. So it would be covariance between the value of xt was wt plus theta wt minus 1, comma wt plus h plus theta wt plus h minus 1. So now we'll take the values differently. If h is equals to 0, if h is equals to 0, so this covariance will become covariance of xt and xt, t plus h will become t only. So it would be nothing but variance of xt, and variance of xt we have calculated is nothing but 1 plus theta square into sigma square. If h is equal to 1, then covariance will be covariance of xt and xt plus 1. This would be covariance between wt plus theta wt minus 1 wt plus 1 plus theta wt. This would be the case. Now I am writing covariance terms. Covariance between wt and wt plus 1. First one would be. Second one would be covariance between wt and wt theta. Theta comes outside here. Plus covariance between theta comes outside wt minus 1 and wt plus 1. Plus theta comes outside of both of them, it will become theta square, covariance between wt minus 1 and wt. So this and this, there is no relation between no covariance between the two values, so all of these will be 0 and we are only left with theta into covariance between wt and wt, which is variance of wt, and variance of wt we all know that it is theta sigma square. So for h equals to 1 is also this, and for h equals to minus 1 is also this. So h equals to plus minus 1 is this. For all the values above h, above 2 and for more than 2, it would be 0 because there would be no common thing. Here wt is coming common. If we take, okay, let us do it. For h equals to 2, then the covariance becomes covariance between wt plus theta wt plus 2, sorry, wt only, plus theta wt minus 1 and wt plus 2 and theta plus theta wt plus 2 minus 1 would be theta t plus 1. If we take wt with t plus 2 and wt with t plus 1, no common term, covariance between them is 0. And if we take wt minus 1 with t plus 2 and t minus 1 with t plus 1, again covariance is 0. So it will be 0 on the whole. So our autocovariance function, let us represent it like this. Gamma h with lag h value is given by theta square sigma square theta square plus 1 into sigma square theta into sigma square and 0. This is when the lag is 0. This is when the lag is plus minus 1, and this is when the lag is greater than or equal to 2. We can also write this as modulus of h is equals to 1, and we can also write this as modulus of h is greater than equal to 2. Anything you can write, your answer is correct. So this is our autocovariance function. Now we have to find out the autocorrelation function, which is represented by ACF. What is ACF? Autocorrelation function. Autocorrelation function can be written as rho h with lag value h given by rho h gamma h upon gamma naught. Now gamma naught is nothing but value of the autocovariance function at lag 0, which is nothing but variance only. So 1 plus theta square into sigma square. Now for h equals to 0, rho h would be 1 plus theta square upon sigma square upon 1 plus theta square upon into sigma square. These will be get cancelled and we will left 1. Or simply we can also write this as rho 0 upon gamma 0 upon gamma 0, which is also equals to 1. For h equals to plus minus 1, the value of rho h would be gamma h gamma 1 upon gamma naught. Gamma 1 was theta into sigma square and gamma naught was 1 plus theta square into sigma square. Now we know that it is an even function, so it also can be written as minus 1. That's why we have taken plus minus 1. So this would be nothing but theta upon 1 plus theta square. And for h greater than equal to 0, since since gamma h is also 0, the autocorrelation function will also become 0. So it would be, I can represent autocorrelation function as 1 theta upon 1 plus theta square and 0. 1 when h is equals to 1, 0, sorry, when h equals to 0, theta upon theta square when h modulus of h equals to 1, and 0 when modulus of h is greater than equal to 2. This becomes our autocovariance function. Now partial autocorrelation function. Now partial autocorrelation function can be written as PACF, partial autocorrelation function. For h equals to 1, the first partial autocorrelation function is represented by phi 1 1. It is equal to r rho 1. The second autocorrelation function is represented by phi 2 2. It is nothing but 1 rho 1 rho 1 rho 2. You just have to remember the formula. There is no derivation required. 1 rho 1 rho 1 1. If we take this becomes, the determinant of this becomes rho 2 minus rho 1 square upon 1 minus rho 1 square. So this is our partial autocorrelation function for this. And if we keep the values of rho here, so rho 2 at lag 2 is nothing but 0. So I can replace this as 0 minus rho 1 square. The value of autocorrelation function at 1 is theta upon 1 plus theta square. So it would be theta upon 1 plus theta square upon 1 minus theta upon 1 plus theta square. Solving this on the next page, we are solving for partial autocorrelation function. So it would be minus theta square upon 1 plus theta square whole square upon 1 plus theta square whole square minus theta square divided by 1 plus theta square whole square. This and this gets cancelled. We are left with minus theta square upon 1 plus theta square plus theta raised to the power 4 plus 2 theta square minus theta square. And this would give us phi 2, 2 is nothing but minus theta square upon 1 plus theta raised to the power 4 plus theta square. So this would be our answer of partial autocovariance function at lag 2. Similarly, we can do for MA2 and MA of order 2, moving average of order 2 and moving average for order P as Q as well. You can try that for your own, and if you face any doubts, then you can ask on the comment section or on our WhatsApp channel. Only relevant doubts will be answered. And I hope that you are simultaneously doing the questions regarding the topics we are covering. And if you're not, then you should try. And if you face any doubts, then you can ask on our WhatsApp channel. We're always available for you, for your help. We are only here for your help only and for your benefit. So take advantage of us and keep on working hard, and all the best. Thank you.